We have a plane flying west at 600 kilometers an hour. It's subject to a strong north wind blowing across it at 200 kilometers an hour. This is obviously going to push the plane further south of its expected path. We can show this as a vector diagram. We draw a horizontal line to represent the velocity of the travel west, a vertical line to represent the north wind. Each of these is drawn to scale, and the scale we've chosen here is 1 centimetre to 100 kilometres. It makes it easier if diagrams are drawn on graph paper. The two velocities that affect the aircraft are drawn head to tail, and the resultant of these is from the beginning of the first vector to the end of the second. That is the resultant. We could actually find the resultant by simply measuring it on the diagram. However, that measurement is difficult to do accurately, and it's probably easier to make a calculation. Now, that calculation can be done using Pythagoras' theorem, that because it's a right-angled triangle, the square of the length of one side plus the square of the length of the other is equal to the square of the hypotenuse. So r squared here is 600 squared plus 200 squared. Now 600 squared is 360,000 and 200 squared is 40,000. Adding these together is 400,000, and therefore r is the square root of that number. Probably have to use a calculator to do that, and the square root of 400,000 is 632, or just over 632, slightly less than the amount that we measured on the diagram. When you complete a calculation, don't forget to put the correct units at the end. So in this case it's a velocity 632 kilometers per hour. Our second calculation is to find the direction in which the aircraft travels. So we need to find the angle theta shown on the diagram. Tan theta is opposite over adjacent. That on this diagram is 200 over 600. 200 over 600 is 0.33. We have to find the inverse tan of 0.33, which is 18.26 degrees. That is the bearing south of west in which the aircraft is travelling.